Hello, this is Eric Lanke, President and CEO of the National Fluid Power Association, and this is a short presentation on the U.S. fluid power industry recorded on October 10th, 2023. Let me start with just a few words about NFPA. The National Fluid Power Association is the trade association representing the hydraulics and pneumatics industry. Our members represent the entire fluid power supply chain. 57% of our members are manufacturers, the companies that design, manufacture, and sell fluid power components, such as pumps, valves, cylinders, and hoses. 30% of our members are suppliers, the companies that provide raw materials and other services needed to make those components. And 13% of our members are distributors, companies that build, integrate, and sell systems comprised of those components. As an association, our mission is to strengthen the fluid power industry, and we do that by focusing on our four strategic objectives. We provide an effective forum where our members can connect with each other and with their customer OEMs to help advance their collective interests. We provide business intelligence and fluid power industry statistics that helps our members improve their decision making. We provide opportunities and resources to better promote the unique strengths and inherent advantages of fluid power technology. And we help build an educated workforce by increasing the number of technical college and university students educated in fluid power and connecting them to careers in our industry. Now, as I just mentioned, fluid power is a term that describes two related technologies, hydraulics and pneumatics. Both technologies use a fluid, either a liquid or a gas, to transform power into controlled motion, and it is a workhorse of the U.S. economy. Fluid power systems transmit more power in a smaller space than other forms of power transmission, making it the cross-cutting technology of choice for dozens of industries and hundreds of applications. Among its many advantages, hydraulics offers a high power-to-weight ratio, high torque at very low speeds, the ability to hold that torque constant, and overall ruggedness and reliability. And among its many advantages, pneumatics is comparatively inexpensive and lightweight. It offers simple control systems. It is clean and non-reactive in magnetic environments, and it activates with extreme speed and precision. Because of these advantages, once you know where to look, you'll find fluid power just about everywhere. NFPA uses the social media hashtag #OnlyFluidPowerCan to educate the general public on fluid power's impact on their lives. For example, in aerospace, we can say, "Only fluid power can lift a jumbo jet, bank and roll a fighter plane, and keep a rocket on course." And you'll see fluid power performing similar functions, moving heavy things with precision in dozens of other markets: power generation, construction and mining equipment, cars and trucks, agricultural equipment, entertainment, metalworking, utility trucks, factory automation, food processing and packaging, material handling, and biomedical are some of the major markets where you'll see fluid power in action. It is this ubiquity of application that makes fluid power such a powerful tool. And so, for those who decide to pursue a career in it, there is always plenty of diverse and exciting things to do with this technology. And here's what to look for. The next time you have a chance, look closely at one of those pieces of construction or agricultural equipment, and you'll undoubtedly see all the major components of the basic hydraulic system. Understanding a fluid power system means following the fluid as it makes its circuit, and the fluid is the most essential component of all. It begins in the tank or the reservoir. From there, it is drawn into and then turned into pressurized flow by the pump, which sends it on to the rest of the system. Most hydraulic systems first have a relief valve that allows overpressurized fluid to return safely to the tank. Otherwise, the fluid is sent through a series of control valves, which can direct the flow to the various actuators on the machine to do the work. Here we see only one actuator, a cylinder, that can extend or retract depending on which end receives the pressurized fluid. Cylinders are usually the most visible component. Picture the long cylinders that lift the bulldozer's bucket and load into the air. But an actuator could also provide rotary motion to turn a wheel or otherwise propel the machine forward. When the work is done, the unpressurized fluid has to return to tank. But before doing so, it usually passes through a filter to keep it clean, and sometimes a cooler or a heat exchanger to remove any excess heat that has been built up. From the tank, the fluid starts the same circuit over again, returning to the pump for repressurization. Your basic pneumatic system operates on many of the same principles, but usually even fewer components are used. The next time you're in an automated factory, look closely at the production machines, and you'll undoubtedly see all the major pneumatic components. Not shown here is the air compressor, which feeds the pneumatic system with the pressurized air it needs to function. That air first passes through an air preparation module, sometimes called an FRL for filter, regulator, lubricator, which cleans, controls the pressure, and slightly lubricates the air to minimize damage to the downstream components of the pneumatic system. Control valves are also used in pneumatic systems, which direct the airflow to the various actuators on the machine. And those actuators are almost always cylinders, providing quick and precise linear motion, extending and retracting depending on which end receives the pressurized air. When complete, the remaining air is usually vented safely to atmosphere, which is what makes the hissing sound associated with most pneumatic systems. So when we talk about the U.S. fluid power industry, it is the manufacture of these components that we are talking about. The pumps, the motors, the valves, the cylinders, the actuators, and the hoses and fittings that connect them all. As you can see by this chart, that industry is about a $21.5 billion business in the United States. That's our average over the last 10 years. 2022 was the largest year on record, with U.S. shipments of fluid power products coming in at $25.6 billion. Of that total, roughly 75% of the business is hydraulics, and 25% of the business is pneumatics. We estimate that there are about 800 companies in the United States that make fluid power products, and several tens of thousands of companies that make machines that rely on fluid power products for their operation. And one thing that all those companies have in common is the need for workers, especially workers who are educated in fluid power. NFPA members consistently tell us that this is among the most challenging issues that their businesses are facing. And that's why we've invested so many of NFPA's resources in bringing fluid power education and activities to schools around the country. When we ask our members about the positions that they most need to hire, this is what they tell us. They need design engineers, people who can design fluid power systems and components, as well as develop new concepts, applications, and improvements of existing installations. They also need sales engineers, people who can market and sell fluid power systems and components, working closely with fluid power manufacturers, distributors, and customers. They also need mechanics, people who can assemble and install fluid power systems and components, as well as troubleshoot and maintain systems on machines that are used in every facet of industry. And they also need technicians, people who can operate the machines equipped with fluid power systems, as well as manufacture and test fluid power systems and components. Take a close look at the fluid power system on the vertical drill that's pictured on this slide. Machines like this are used to drill into solid rock, harnessing and focusing the incredible forces of their hydraulic systems for what would otherwise be an impossible task. Creating these complex systems, designing them, selling them, assembling them, and maintaining them, this is the challenging and rewarding work that the fluid power industry has to offer. Anyone with a mechanical aptitude and a desire for variety in their work is a potential hire for our industry. And NFPA is doing its part to help develop a new, educated workforce for the fluid power industry. Through our charitable foundation, we are working with schools across the country to grow the number of students being exposed to fluid power and receiving industry-validated fluid power instruction. Right now, this network of educators includes schools in 27 of the 50 U.S. states, and they scale across many grade levels. We have 228 middle schools, 164 high schools, 102 technical colleges, and 90 universities, all working with us to bring more fluid power to their students. Spanning all those grade levels is important because as fluid power interested students move from middle school to high school and from high school into higher education, we can better provide education and recruitment programs that translate into workforce pathways for our industry. So stacking these programs within each individual state becomes key. One of those stackable structures is Fast Track to Fluid Power. Fast Track is a workforce development pathway that connects local technical colleges with industry partners and with high and middle school teachers. The network creates awareness and interest in fluid power and continues to direct students along a path that leads to careers in the fluid power industry. There are 4 key programs that are nested together in this structure. The Fluid Power Action Challenge engages thousands of middle school students in learning about and having fun with fluid power. Then Fast Track high schools are each equipped with fluid power lab equipment and curriculum. They teach real-world fluid power and generate interest in fluid power careers. Then fluid power scholarships are offered to graduating high school students in order to pursue fluid power degrees or certificates at designated technical colleges. And finally, Fast Track technical colleges are schools with a 2-year degree program which has been validated to teach core fluid power competencies. The result is a stream of talented and interested young people, well prepared and ready to go to work in those mechanic and technician positions in the fluid power industry. Another stackable structure is our Power Partner Universities. These are 4-year schools that excel at teaching and connecting their students to fluid power instruction and to career opportunities. In order to qualify, a university must consistently conduct 4 major activities. First, they must teach the fluid power competencies identified as most important for entry-level engineers by the fluid power industry. Then they must have an undergraduate fluid power club on their campus that meets regularly and connects students to fluid power resources. Then they must have a team participate in our Fluid Power Vehicle Challenge, a design-build competition that challenges students to build a human-powered fluid power vehicle. And finally, they must host an industry connection event on their campus to introduce fluid power-educated students to companies in the fluid power industry. When it comes to sourcing candidates for the design and sales engineer positions needed in our industry, NFPA members are increasingly engaging in these same activities at our Power Partner Universities. These programs have created a lot of educational momentum for fluid power, and a big piece of that momentum has been the accelerating pace of fluid power research being performed in our nation's elite institutions. Truth be told, 30 years ago, there was very little R&D going on in the fluid power industry. It was perceived to be a reliable but a mature technology with little room for advancement. All of that began to change in 2006, when the industry and many of its academic partners came together to win a $40 million grant from the National Science Foundation to create the Center for Compact and Efficient Fluid Power. Headquartered at the University of Minnesota, the CCEFP engaged 6 other universities and conducted hundreds of industry-directed research projects that have resulted both in fluid power technology advancements and in the creation of a new generation of academic research faculty for fluid power. In 2017, the CCEFP helped create a new $5 million a year research program within the U.S. Department of Energy, which is focused on improving the efficiency of fluid power systems in off-highway vehicles. That program has created even more research infrastructure for fluid power, including an expansion to more universities and the development of dedicated resources at 3 of our national laboratories. Our industry is actively engaged with all of these institutions. Compared to 30 years ago, a nationwide network of research universities and laboratories are working actively with the fluid power industry to address the research challenges associated with ongoing product and system improvements. To help guide these efforts, NFPA has published, and for a number of years now has maintained, a technology roadmap for the fluid power industry. This document identifies the key challenges for future research and development that will be necessary to better meet the changing needs of our customers. This is a complicated slide, I know, but what it shows is crucial if you want to stay ahead of technology trends in the fluid power industry. On the left is a list of customer strategies. We work closely with the actual machine builders that use hydraulics or pneumatics to power their machines, and with their help, the roadmap first identifies these strategies, the machine-level objectives and technologies that those machine builders have in order to achieve the performance objectives of their own customers. For example, when John Deere builds a tractor and they want to sell it to a farmer, they need to make sure that their tractor offers the productivity, availability, the cost profile, and the regulatory compliance that that farmer is seeking. To do that, machine builders like John Deere are increasingly turning to these technology strategies. They are making their machines more autonomous. They are making them more compact in design. They are connecting them to the cloud and other data monitoring devices. They are electrifying their power sources. They are increasing their energy efficiency. They are lowering their maintenance requirements. They are incorporating more environmentally friendly and sustainable materials. And they are lowering the level and harshness of the noise that they emit. That's what's happening to the machines that rely on fluid power for their power and control systems. In response, our roadmap lays out the list of capability improvements that you see on the right. If fluid power is going to remain the actuation technology of choice on these machines, it has to play a role in these machine-level strategies. And the capability improvements are the areas where continued advancement is both happening and probably where it needs to be accelerated. The future of fluid power is a technology that actively uses data from its own operation to make it easier to use and apply, to increase its energy efficiency, to lower its environmental impact, to lower its noise emission, to increase its power density, to increase its reliability and durability, and to improve its safe use and application in the field. Future fluid power engineers will not just be mechanical engineers, they will need to be data and computer scientists who can help these systems adapt to a changing environment in real time, and sometimes without human intervention. Let me end by talking about just 2 examples of improvement trends, both of which are dramatically impacting the fluid power industry. The first is electrification. Fluid power is used in 2 primary settings, either in an industrial plant, where an electric motor is almost always the prime mover in the system, or on a piece of mobile equipment, where traditionally an internal combustion engine is almost always the prime mover. What's happening now is that in an effort to reduce emissions from those internal combustion engines, they are being replaced with an electric power source, an electric motor, a battery pack, or some combination of those technologies. In many cases, the hydraulics that controls the actuated functions on the machine remains. Remains because the machine needs the power density of fluid power to perform its tasks. But optimizing a hydraulic system to perform with an internal combustion engine and optimizing one to perform with an electric motor, especially in the confined and compact architectures associated with off-highway equipment, are two very different things. The schematic that you see here shows an electric hydraulic hybrid solution for the propulsion system on this wheel loader, and that is certainly one possible application. But more necessary is a similar electric hydraulic hybrid system to perform each of the actuated functions on the machine: pushing the bucket, lifting the bucket, dumping the bucket. Increasingly, those needs are pushing our industry towards distributed hydraulic systems, not a single pump driving a variety of functions through a valve bank like I showed earlier, but a series of smaller, more compact motor pump actuator units, one for each function on the machine. That's a radical change, and many companies in our industry are now developing innovative and cutting-edge products to optimally perform in this space. The second improvement trend in fluid power is connectivity. The proliferation of sensors and internet-enabled technologies is hitting just about every industry. We're increasingly familiar with a whole slew of household products that we can now monitor and control from our phones, from doorbells to thermostats to refrigerators. Well, all of the machines that use fluid power technology for their actuated functions are also utilizing these technologies. In fact, they started using them long before your doorbells and your thermostats. So much so that the entire technology trend is sometimes called the industrial Internet of Things. And those capabilities are now increasingly being incorporated into fluid power components and systems. Through sensors, internet connectivity, data analytics, and automated control functions, we're now in a place where not only can an operator or owner monitor what is happening in real time on their machines, doing that on their phones or through dashboards like the ones you see on the screen, they can now rely on the machines to trim and in some cases fix themselves in order to maintain optimal performance levels. For fluid power, that means knowing in real time things like fluid conditions, actuator positioning, component wear and life cycle, and then engaging in either predictive maintenance or automated control functions. Here, like electrification, our companies are developing new and innovative solutions to these challenges and bringing more and more intelligent and energy efficient technologies to their customers. If you want to learn more about this modern world of fluid power, one way to do that is to subscribe and listen to our podcast, Fluid Power Forum. Every other Monday, we post a new episode in which I interview someone who is helping to move fluid power technology forward. The podcast is a great way to hear what is new and exciting in our industry and to connect with the people who are truly shaping our future. I would encourage you to subscribe, listen, and share the episodes that have the greatest impact on your understanding of fluid power. So I hope I've left you with the view that fluid power is a modern and thriving technology. Hydraulics and pneumatics can be found in hundreds of applications and are the driving force for dozens of critical industries. If you have questions or would like to learn more, please feel free to contact me by email or visit our website at www.nfpa.com. Thank you.